All right, we're going to jump into lesson 11.3/11.4, which is going to be on solving systems by elimination. We've already looked at two methods to solve these systems of equations. The methods we've already looked at are solving by graphing and solving by substitution. And this is another method that you can use, right? All of them will get you the same answers, but some of the times it's easier to use one than it is to use others. So you want to have them all in your toolbox. So the steps for solving by elimination. It says first stack the equations and variables. So we kind of want to have the x's above the x's and then the y's above the y's. And then we want to have these constants, the numbers on the other side of the equal sign. So it's basically in standard form of a linear equation here. And then instead of putting them side by side like we did for substitution, we're just putting one on top of the other here. And it then says get the coefficients of one variable to be opposites. So if you check the first example, we have a -4 and we have a +4. So the coefficients of the x's are opposites. So that part's already done for us on that problem, but we'll want to do that if it's not done. And then you eliminate opposite variables and solve, and then you're going to have to solve for the second variable as well. And we'll talk about how to do that here. So like I said on this first one, they've already got a lot of it set up for me because we've got the x's above the x's, the y's above the y's, and we've got the numbers on the right side there of the equal side, and everything's in standard form. And then the other part is we've already got a -4 and a +4 in front of the x's, so those coefficients are already opposites. So we're ready just to start eliminating here. And basically we do this like adding like terms. So -4x and +4x, those cancel out, right? That's why we have this elimination, or it's also called combination sometimes. And so then we have 8y minus 5y, which is 3y. And then adding on the right side here, -26 plus an 8, a +8 gives me -18. And now I just have to divide both sides by 3. And we end up with y equals -6. And so that's half of the answer there, right? Half of the equation, or half of my answer there. And now I need to go ahead and find the second part, the x value in this. And so I can choose either one of these equations. I can choose the top equation, or I can choose the bottom equation and plug my y value in there. I'm going to go ahead and pick the bottom equation just because it has some smaller numbers, although you can choose whichever one you prefer. And so we're going to end up here with 4x minus 5. Instead of putting the y that's there, I'm going to replace it with what I have, which is -6. And that equals 8. And now I'm going to go ahead and solve this. So I get 4x plus 30 equals 8. And now I'm going to subtract 30. I get 4x equals -22. And then I'm going to divide everything by 4. And I get x equals -5.5. And so that's the second part there. And then remember, my final answer needs to be written x comma y, so we'll go ahead and do that. And so we're going to end up with -5.5 comma -6. And we get our final answer there. So that would be one solution, right? Those would intersect on the graph, and that would be where they would intersect, -5.5, -6. Okay, we'll keep going here. Same idea here. For this one, notice we've already got the y's stacked up, we've already got the x's stacked up, and we've already got the numbers on the other side. The problem is we don't have any coefficients that are opposites. Okay, I want you to notice that this 3 and -6, they're opposite signs, right? But they're not quite opposite numbers. So what I'm going to do is I'm going to manipulate that top equation by multiplying it by something so that I can get it to be an opposite of -6. So what would I have to multiply this 3 by to make it a +6, right? And that would be 2. So I'm going to multiply everything in that top equation by 2, and I would end up with this. +6x plus 4y equals 12. Okay. And now I can go ahead and use my elimination method, right? I'm not really looking at this top equation anymore because I've just multiplied it by 2 and moved it down below here. Okay, so I'm not really using that one anymore. And so we're going to end up with this. 6x and negative 6x, those are going to cancel out, which is what I want. And then I get negative 3y plus 4y. Well, that's just 1y, and that equals a positive 6. And then this one doesn't really require any extra work, so that's kind of nice. We got half of our answer there. We just need to go ahead and find the y coordinate now. And so once again, I can take this y equals 6 and plug it into either of my original equations, right, or my manipulated equation, whatever one I want. I'm going to go ahead and plug it into this top equation here, and so we'll end up with 3x plus 2 times 6 equals 6. And now I'll go ahead and solve this. 3x plus 12 equals 6. So that means 3x equals negative 6. And dividing by 3, I get x equals negative 2. And so then I've got my x coordinate there. And then, of course, my final answer always has x comma y, so I'll go ahead and write that. So that's going to be negative 2 comma 6. So that would be one solution on a graph, right? They would intersect at one point at negative 2, 6. All right, moving down below, example 3, getting even trickier here. Okay, notice we've got the variables stacked, right? X is on X, Y on top of Y, numbers on the right side, so that part's good. But we don't have any opposite coefficients right now. The good news is for the Y's, we have opposite signs, right? We have a positive 4Y and a negative 5Y, but they're not opposite numbers. We need them to be opposite numbers. So I can kind of think of this as an LCD, right? What can I turn them into so that they'll be opposites of each other? And what I'm going to do is this. I'm going to multiply this top equation by 5, and that's going to give me 15x plus 20y equals negative 30. And then I'm going to multiply this bottom equation by 4, and that's going to give me 8x minus 20y equals 4 times 19 there is going to give me 76. Okay. And so what I did here is I forced these y's to be opposites of each other by picking 5 and 4 to multiply by. So you got to try to figure that part out on your own, right? It's like finding a common denominator, but we can see now that we have positive 20 and negative 20 here, and so those are going to cancel out. And so then we're just left with 15x plus 8x, which is 23x, equals, this is going to be a positive 46. And then I'm going to divide both sides by 23, and I get x equals 2. So we got half of the answer there, right? I need to find the other half, the y coordinate. So I'm going to go back into either one of my equations here. Hey, I'm going to pick this bottom equation to plug into, and we're going to end up with 2 instead of x. We're going to have a 2 there, so 2 times x, but instead 2 times 2, because that's what I have over here, minus 5y equals 19. And now I'm going to go ahead and solve 4 minus 5y equals 19. Subtract 4 to the other side, and I'm going to get negative 5y equals 15. And then divide both sides by negative 5, and I get y equals negative 3. Okay, and now we got to write this as a ordered pair, x comma y, my final answer here. Okay, so we're going to end up with 2 comma negative 3, always x comma y. This would be one solution on a graph. They'd intersect at one point at 2, negative 3. All right, we'll move to the next page here. Okay. So same start here, right? We can see this is nice. They've already got it set up. X and Y above each other, numbers on the right side. So that's all good. Okay, we need to get something to be opposite. So what I'm going to do is I'm going to get these X's to be opposites. This is negative 2X. I want this one to be positive 2X. So I'm going to go ahead and multiply the entire equation by 2. Right? You have to do the whole equation. You can't just do a part of it. And so this is like distribution. So everything in there is getting multiplied by 2. And I'm going to move it down below. It's going to be 2x plus 6y equals positive 4. Okay. And so now we're left here where we can cancel out these x's. And then what's happening is when we combine the y's, they also cancel out. And so I'm just left with nothing over there, which is the same as 0. But notice also over here, negative 4 and positive 4, they also cancel out. So I'm left with 0, and we have 0 equals 0. And you remember, if all the variables get canceled, then there are two options. Okay, you can either have no solution, or you can have many solutions. For this one, we have a true statement, right? 0 does equal 0, which means we have infinitely many solutions. And hopefully you remember, if you were to graph that, that means these two lines would just be laying on top of each other. Okay, I want to go down to example 5. Example 5 is pretty nasty looking because it's all sorts of fractions. You could start to fraction bomb this if you wanted to, and you'd get the right answer, but I want you to notice what the fractions are here, because we've got x above x and y above y, right? And we've got these numbers on the right side, so everything is set up nicely. And then also we've got 1/2 here and negative 1/2 x there. So we know those are going to cancel. We've got negative 7/9 and positive 7/9, so I know those are going to cancel. So without doing any fraction bombing, right, I can just look at this and say, okay, well, 1/2 and negative 1/2 is gone, right? And then also negative 7/9 and positive 7/9 over y, that's gone. So I'm just left with 0 on the left. And then I have these numbers on the right, and right now they're pretty challenging to deal with because one's an improper fraction and one's a mixed number. So what I'm going to do is I'm going to go ahead and rewrite this 6 2/3 as a improper fraction, and that would be 20/3. Okay, and so then we can see, well, in this case, we're also going to have negative 20/3 and positive 20/3, and those things are going to cancel out, and we're going to be left with 0 on that side, and so we get equals 0. And so once again, this is a true statement, which means we have infinitely many solutions. All right, moving to example 6. Okay, same idea here. Everything's set up for me nicely, so I'm going to go ahead and start to cancel things here. So we've got 12x and negative 12x. Okay, well, there's a problem because they're not opposites. They're identical, right? So I need to get these things to be opposites. So what I'm going to do is I'm going to multiply this top equation, right? I keep multiplying the top, but you can multiply whichever one you prefer, right? I'm going to multiply the top by a negative 1. Because if I multiply by a negative 1 and then I distribute, it's going to turn into positive 12x and then minus 2y and then equals positive 4. And so now we have this setup here where we can start to cancel things out, because we have a negative 12y and a negative 12x and a positive 12x. So we'll go ahead and start to cancel here. And we're going to see the x's cancel out. And then the y's also cancel out, and so we're left with 0 on the left because everything canceled out, and negative 2 and a positive 4 gives me a positive 2. And so in this case, we have a false statement, which means we have no solutions. And hopefully you remember from a graph, that means that these things would be parallel lines, never intersecting. All right. And we'll go to the last one here, which is a word problem here. It says, Jamian bought a total of 35 bagels and donuts for a morning meeting. He paid a total of $29.75. Each donut cost 70 cents and each bagel was $1.05. And they give me a system of equations here, right? Two equations, two variables, that's the system. And now we need to go ahead and solve this system to figure out the number of bagels and donuts that this person bought. So as we zoom into the equation here, or the system here, notice we've got B and B stacked up and D stacked up, and we've got these numbers on the right side. So the setup is right. We just need to figure out how to cancel out one of these variables. You can choose whichever one you want. I'm going to go ahead and cancel out the B's. If this is positive 1.05, I want this to be negative 1.05. So I'm going to multiply the entire top equation by negative 1.05. And so we're going to end up with a new equation, and I'm going to actually move it over here for space. And so we're going to end up with negative 1.05 B minus 1.05 D equals, well, we have to do negative 1.05 times 35, which gives me negative 36.75. And then the bottom equation we haven't touched yet, so this is still just going to be 1.05 B plus 0.7 D equals 29.75. And now we've set it up so that these are going to cancel out. So we end up with the B's canceling out, which is what we want. And now we can go ahead and combine like terms or just add or subtract here. So we've got negative 1.05 D plus 0.7 D, which gives me negative 0.35 D equals, on the right side here, I'm going to end up with negative 36.75 plus 29.75. That gives me negative 7. And then I need to divide both sides by negative 0.35. And I'm going to end up with D equals positive 20. Okay, and so that's half of it there, right? So that's 20 donuts for that part, 20 donuts. Okay, and then we also need to remember, well, they wanted me to find how many bagels as well. So I know that there was a grand total of 35 items purchased here. And if 20 of them were donuts, that means that the remaining would have to be bagels, and that means I'm left with 15 bagels. All right, that's it. Thanks for watching.